I just had to let you know you're
What is differentiation? Differentiation is a technique used to find how quickly something changes compared to another thing. For scenario D, I choose the linear approximation technique. In this situation, the technician needs to estimate the value of square root 145.76 quickly without using a high-end calculator. Linear approximation is suitable because it allows us to estimate values that are close to a known point. Since 145.76 is close to 144, which has an exact square root of 12, the approximation process becomes easier and faster. This technique is very useful in real-life situations when quick estimations are needed while still maintaining reasonable accuracy. For scenario B, the differentiation technique that I choose is first principle. In this situation, the engineer wants to determine the exact velocity of rocket during its launch. Since the rocket's position is given as a function of time, calculus is needed to measure how the position changes over time. In differentiation, velocity is defined as the rate of change of position with respect of time. By taking the derivative of the position function, we can obtain the velocity function. This method is suitable because it provides an accurate and systematic way to analyze the rocket's motion.
For the question 2, I will verify the derivative of the function using the power rule. The given function is fx equals to 3x to the power of 2 plus 5x. The power rule states that if fx equals to x to the power of n, then its derivative is f prime x equals to nx to the power of n minus 1. First, I differentiate the term 3x to the power of 2. So, I keep the constant 3 and apply the power rules to x to the power of 2. So, 2 comes down to the front and the power reduced by 1. Like 3 times 2x to the power of 2 minus 1. So, it equals to 3 times 2x, which is, it becomes 6x. Next, I will differentiate 5x. Since x has a power of 1, applying the power rule gives 5 times 1x to the power of 1 minus 1. So the answer will become 5. Then I combine both derivative. It becomes 5 prime x equals to 6x plus 5, which matches the answer from the first principle of differentiation.
Good day, everyone. Next, we go to next question is question 3, which focus on implicit differentiation. So, let's walk through step by step. So, this question is sin x cubed y cubed plus ln y squared plus 1 equals to exponent 2x minus exponent y. For the step 1, we need to differentiate left hand side. So, we differentiate term by term. Then, we use the chain rule and product rule here. Then, for term 2, y squared plus 1. Again, we apply a chain rule. So, for the step 3, we now bring both sides together, left hand side and right hand side. Then, for step 4, we to collect term with dy over dx. Collect. For the step 5, solve the dy dx. So, The step 6 is find gradient at 0, x0, y0.
Question 4. The question asks us to use linear approximation to estimate the value of 63.98 to the power of 3 over 2 minus 1 over cube root of 63.98 correct to 2 decimal places. First, we need to identify the variables. The problem identifies a value x equals to 63.98, which is very close to a perfect number 64. So, x naught equals to 64 is chosen because it's easy to calculate its square root, which is 8. Then, the difference of x and x naught is calculated, which is 63.98 minus 64 equals to negative 0.02. After that, the expression then converted into a general function f(x), where f(x) is equal to x to the power of 3 over 2 minus 1 over x to the power of 1 over 3. And then we simplified the equation using exponent rules. Then we get the answer, which is x to the power of 7 over 6 minus x to the power of negative 1 over 3. Next, we differentiate the answer, which would be f prime x equals to 7 over 6x to the power of 1 over 6 plus 1 over 3x to the power of 4 over 3. Then we calculate the exact value of the function and its derivative at 64. Fx naught equals to 64 to the power of 7 over 6 minus 64 to the power of negative 1 over 3. The answer is 127.75. After that, we differentiate the answer, which would be f prime x naught equals to 7 over 6 multiplied by 64 to the power of 1 over 6 plus 1 over 3 multiplied by 64 to the power of 4 over 3. The answer is 2.3346. Next, we need to calculate the differentials, which is f prime x naught multiplied by the difference of x and x naught. So 2.3346 multiplied by negative 0.02, and we got the answer, which is negative 0.046692. Lastly, we should apply the linear approximation formula, which is fx approximation fx naught plus differentials. So 127.75 plus negative 0.046692 equals to 127.70.
Laban al